there's these multiple levels, and you build up sort of one by one, or depending on what you already know and what you're comfortable with leaving to models, right? You bring your simulation up to that point, and then do that, and then build onto the next level once you know that you have that lower level sort of down pat. So what I mean by this is, say that we do a bunch of simulations in that single link, and we get, so we understand what the ultimate fidelity is and what the average rate is of generating that entanglement, and we use our simulation to gain that statistics and that and that knowledge. We can then use that to make a model, which we then put on a link, and it generates entanglement with a given rate and a given fidelity, but we don't specify in there how it's happening. We just say make entanglement. And so that will be important when dealing with many more nodes, where you don't necessarily care how each link is really working, as long as you know how often and how well it produces entanglement. And so in general, you have to build up level by level by combining both simulations at lower levels that you've done, or analytical or statistical models that you have. So to this end, right, I'm going to talk a little bit now about this middle level of abstraction, which is when we're talking about repeaters and swapping in longer chains. So in particular, I'm going to be talking about entanglement, an entanglement swapping protocol. So now, whereas before we had our little link, and in that link we had a swapping station that could do entanglement swapping. That's kind of what repeaters are, but repeaters are sort of a souped up version, where they're assumed now to be able to hold and to receive and to hold on to these EEG qubits, i.e. they're assumed to have some amount of memory that they can use, and then when they're ready, perform an entanglement swapping procedure on these qubits, as well as of course message their neighbors classically. So at this level, and in the simulation I'm going to show you next, we don't really care how these individual entanglements are being formed. We just care that within this repeater chain, we get these elementary entanglements formed, so that the repeaters can do their job. So having models about how long that takes and at what fidelity it happens is what we do.